Hello, welcome to this video. Today we're going to solve this problem. So we need to find all numbers x, y, a, m, and n that are natural numbers that satisfy x plus y is a to the n and x squared plus y squared is a to the m. So let's begin. So first of all, I want to establish a small obvious inequality, but we'll prove it. So a to the 2n we know is equal to x plus y all squared. So it's x squared plus y squared plus 2xy. But we know that's bigger than just x squared plus y squared. And that's a to the n. So basically a to the 2n is bigger than a to the n. So 2n is bigger than n. Okay? Now, we need to establish this small inequality. Now let's begin with this. So let's look at this number, 2xy. We know this is equal to x plus y all squared minus x squared minus y squared. We know this is a to the n, and this is a to the n. So this is a to the 2n minus a to the n. And because 2n is bigger than n, I can factor out an a to the m here and get this is a to the 2n minus n minus 1. And, okay, another thing I want to establish is because x and y are natural numbers, a to the n, which is equal to x plus y, is bigger than or equal to 2. So a is bigger than or equal to 2. Meaning that this, we know it's a whole number, and it cannot be 0, because that would require a being 1. So this is a natural number. And I also need to mention, in this problem, by natural number, I mean a positive whole number. I'm not including 0. Although it would be easy to look at the case of 0, I won't be doing it. I'll leave it for you to fill up, to continue that. But now, let's look at a very special number called x minus y squared. We know this has to be bigger than 0 because it's a square of a real number. And we know this is x squared plus y squared minus 2xy. So, we know what's x squared plus y squared. It is a to the m, and we know what's 2xy. A to the m times a to the 2n minus m minus 1. But now, this is a to the m times 2 minus a to the 2n minus m. And we know this is bigger than or equal to 0. And a to the m is obviously bigger than or equal to 0. So we end up with 2 being bigger than or equal than a to the 2n minus m. But this cannot be 1 because that would require a being 1. So this is also bigger than or equal to 2. So we get from here a to the 2n minus m is equal to 2. And now, before I continue with this gives us, before I continue with what a is and what n and m, the relationship between them, let's look at x minus y squared. Because now we know this is a to the m times 2 minus, well, this is 2. So x minus y all squared is 0. So x is equal to y. And we'll use that later. But now let's look at this. A has to be bigger than or equal to 2. But if a to some power is equal to 2, a has to be equal to 2. And the power has to be 1. So 2n minus m is 1. So m is 2n minus 1. Now, we know that x is equal to 1. We know what a is. Let's plug it into the first equation. We'll get 2x is equal to 2 to the n and x is equal to 2 to the n minus 1. But we know this is also equal to y. And now we can check. X plus y is 2 to the n minus 1 is 2 to the n, which is 8 to the n, works. And x squared plus y squared is 2 times 2 to the 2n minus 2, so 2 to the 2n minus 1, and we know indeed m is 2n minus 1 and a is 2. So, all in all, our final solution is for all n that are natural numbers, x is equal to y, which is equal to 2 to the n minus 1, a is equal to 2, and m is equal to 2n minus 1. And of course, our n stays the same n. So, this is the final solution of the problem. And if you want to fill in the cases of if there are zeros, you can do it yourself. It's not that hard. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting content like this and things like this in the future. And finally, that's it.